Part 2 of the Unit 1 and Unit 2 CBA review, talking about subatomic particles and how they are related to the periodic table. First of all, we have to figure out how we find an element on the periodic table. Which one's which? The atomic number, also known as the number of protons, determines the identity of an element. I'm going to highlight the ID and identity because the atomic number is like an element's ID number. If you're figuring out an unknown element, it'll help if you know the number of protons. Also remember that protons match the number of electrons. And if you know the number of protons, which matches electrons, you know that element's atomic number. If you know that element's atomic number, simply look up its name on the periodic table, and now you know what you're looking at. Mystery solved. An easy way to remember how to find missing information is by using the acronym APEMAN. APE is all in the same font because all of these numbers are the same. The atomic number.
Javon Price, please go to the choir room. Javon Price, please go to the choir room.
Equals the number of protons, which equals the number of electrons. These letters in man are all different because they're all different numbers. The M in man stands for mass number. The A stands for atomic number, which we already had to find over here. And the N stands for neutrons. To find the number of neutrons in an element, subtract the mass number by the atomic number. On our periodic table, remember that the atomic number is at the top, the mass number is at the bottom, down here, and this key is available for you on your reference materials for testing. Now let's practice. In a model of an atom, which subatomic particle, so the answer is going to be a subatomic particle, will tell you the element you're looking at if the model isn't labeled. Which particle determines identity? Protons. If the element isn't labeled, you can look at protons to determine what you're looking at. Number 4. What is the purpose of atomic numbers on the periodic table? The number tells us an element's identity. This is because the atomic number is the number of protons. And the number of protons in an atom is unique for each and every element. Number 5. This picture is an accurate representation. Accurate means correct. Representation means model of which element? Remember, if you don't know what you're looking at and it shows you the number of protons, you can simply look it up on the periodic table. This model has 7 protons. If I look at the periodic table and find the atomic number of 7, which is here, I know that I'm looking at nitrogen. How many neutrons are in an atom of xenon? In order to complete this problem, I'm going to have to complete my APEMAN steps. APE, M minus A equals N. And then I'll have to find xenon on the periodic table. Xenon is here in our noble gases family, and xenon's atomic number is 54. That means it has 54 protons, and it also has 54 electrons. Atomic number is also located over here in the man steps, so I'll go ahead and fill that in. Xenon's atomic mass is 131.294. 131.2 stays at 131. It does not round up to 132. 132 minus 54 equals 77. And there's my answer. Xenon has 77 neutrons. Number 7. An element has 47 electrons. What is the element's atomic number? If you remember, 8-man, the number of electrons is the same as the number of protons, which is the same as the atomic number. So if an element has 47 electrons, its atomic number is 47. A equals P equals E. That concludes Part 2, subatomic particles in the periodic table.